GCF can be 11, for example, because 11 doesn't go into 2. It can be 5, because 5 doesn't go into 2. It can't be 4, because 4 doesn't go into 2. The only thing that goes into 2 is 2. So the only thing that may go into all three of them is 2. Because that's the only thing that goes into the first number. And coincidentally, 2 does go into 4 and 12. So we can factor out a 2. In addition, each term has x to a power. Well, you factor out x to the smaller power. Between these three numbers, 3 is the smallest. Okay, now you ask yourself, 2 times what gives you 2? 1. Minus and plus. Minus and plus. 2 times what gives you 4? 2. 2 times what gives you 12? 6. So I have all the numbers right. Now we have to worry about the x's. Remember, when you multiply x's, like x to the 5th times x to the 13th, for example, you add the exponents. Well, x cubed times x to the 2 gives you x to the 5th. Why? Because 3 plus 2 is 5. 3 plus 4 gives me 7. 3 plus 0 gives me 3. Now all we have to do is clean this up a little bit. 1 times x squared is simply x squared minus 2x to the 4th plus x to the 0 is 1. 6 times 1 is 6. There's your answer. Here's your answer. Simplified. Suppose you have this problem. So, these are the three terms. Let's find the GCF of 36, 18, and 27. 36 is 9 times 4. 3 squared times 2 squared. 18 is 9 times 2. This is a prime factorization. 27 is 3 times 3, which is 9, times the third 3. 3 cubed. Well, between these three, the only thing that's the only base that they all three have is 3. And the smallest power of 3 is 2. So that's the GCF. Now, they all three have A's. 3, 4, and 2. 2 is the smallest. They all three have B's. The smallest power of B that came up is 3. They do not all three have C's. So that's all you can factor out. 9 times 4 gives me 36. A squared times A. 2 plus 1 gives me 3. 3 plus 1 gives me the power 4. Minus 9 times 2 gives me 18. Add the powers of A to get to be 4. 2 plus 2 is 4. B cubed, I don't need any more B's. I have 3 B's in front. That's all I need. That's fine. Plus the 9 in front times 3 gives me 27. I have A squared in front. I have B cubed in front. But I need C to the 7. the 1. Just 4AB. 4AB. There's the answer. Try another one. Suppose you have 7xy minus 3xz. Between 7 and 3, there's nothing goes into 7 and 3 other than 1. So the only thing that's in common is x. What goes in the brackets is everything else. The 7, the y, the minus, the 3, and the z. Everything but what's common goes in the brackets. And that finishes that problem. Now what if I make that problem a little bit more complicated? For example, instead of x, I put a plus b. Now you should think of a plus b as just one letter like C or D or K. I wouldn't say Y or Z because I already have Y's and Z's. Think of it like X. Well, in any case, the factors are, in the first term, 7, A plus B and Y. In the second, 3, A plus B and Z. The only thing that was common was A plus B. What's this? So, in the brackets, put everything else. 7y minus 3z. 7, the y, the minus, just 3 and the z. There it is. You have this problem. Excuse me. They all have 4 as well as 8. Excuse me. They all have 4a in common. Oh, write down 4a and then put everything else in the brackets. That isn't crossed off. There's the answer. Alright, one more. Both of these terms have f plus g. Factor it out in front. Write down everything but f plus g in the brackets. 3